Unit 7, Finance Math. Lesson 5, Solving for Other Variables in Compound Interest Problems. So up until now, we've been focusing on this equation for compound interest. And the first time we looked at it, we knew the principal, and we knew the interest, and we knew the compounding period, so we had n, and we were solving for a. The second time, we rearranged the formula so that it was in the form where we were solving for present value, which is another word for principal. And again, we knew our I, we knew our n, we knew the accumulated amount a, and we were solving for the principal or present value. The two examples that we're going to look at today are solving for the other variables in the formula. So how would you solve for I, or a specific interest rate, and how would you solve for n, or a specific amount of time? So there are two examples in this lesson. The first one is going to focus on solving for a rate. Maria's grandmother has given her the sum of $12,000 to pay for her university education. So she has that money in the present. Maria expects to start university 4 years from now. So there's our time frame, which she estimates the cost will total $17,000. So that's the accumulated amount. That's how much she will need 4 years from the present time. At what interest rate, so we're looking for the interest rate, compounded quarterly, does she need to invest the money? So we have our principal, we have our accumulated amount, we have our time frame because it's 4 years. We know the compounding period, so the only thing that's left that's unknown is the rate. So let's take a look at what we have. We'll start off with our formula. A equals P times 1 plus I to the n. Now we know n is the number of years, which is 4 years, times the compounding period, which also happens to be 4 because it's quarterly. So we have an n value of 16. Our accumulated amount is going to be 17,000. Our principal, what she has now that her grandmother gave her, 12,000. And our interest, well, we don't know what I is, but what is I and what is the formula for calculating I? That's the interest rate, and, can't spell, interest rate divided by the compounding period, which is 4. Well, our interest rate has always had the variable r. When we first saw the small r when we introduced simple interest, r represented interest rate. So I is actually the rate, which is what we're solving for, over 4. So I'm just going to put that in here. I is r over 4, and n is 16. Now take a look at this equation. The only unknown is the r. So we're going to try to rearrange it using our algebra skills and move everything around and solve for r. So the first thing I need to get rid of is the 12,000. So I'm going to start by dividing both sides by 12,000. And so if I do 17,000 divided by 12,000, I'm just going to reduce the zeros and I'll get 17 over 12 equals 1 plus r over 4 to the 16, because this 12,000 reduced this 12,000. 12,000 divided by 12,000 is 1, so that's gone. Now, well, the r is inside this bracket, so I have to somehow get rid of these brackets, but I have an exponent of 16. So think about when you were getting rid of a square when solving in Pythagorean theorem. How did you get rid of a square? Well, you square rooted. So instead of taking the square root, I'm going to take the 16th root of 1 plus r over 4 to the 16. So now the 16th root of an exponent of 16 will reduce. And since I did that to the right-hand side, I have to also take the 16th root of the left-hand side. I'll just move this over here. Okay, now the right-hand side here is going to reduce to just 1 plus r over 4, because by taking the 16th root, we've now canceled those out. And I have 16th root of 17 over 12. Now, if you wanted to, you could rewrite this as a rational exponent. So if you wanted to, you could say, oh, I've missed the bracket here. Sorry, go back. 17 over 12 to the power of 1 over 16. Some of you might prefer that on your calculator instead of doing the 16th root. That's the same thing. And over here, I have 1 plus r over 4. So if I subtract 1 from that side, I can subtract 1 from this side, leaving me with this 17 over 12 to the power of 1 over 16 minus 1 is r over 4. I'm going to actually calculate this, and I'll try to keep as many decimals as possible so that it's accurate. And 0.022007846 equals r over 4. Now the last step here, I have to get rid of the 4, so I have to multiply both sides by 4. I'm running out of room here. And so 4 times this is going to be approximately 0.088. And of course the 4 is reduced on this side, leaving me with just r. And this was rounded, so I'm just going to do a little approximation here. So that means that the rate was 0.088, but that's as a decimal. So to convert it to a percent, it's going to be 0.088 times 100, which is equivalent to 8.8%. So we need our statement here. Maria should invest the money at an interest rate of 8.8%. Therefore, Maria should invest the money at an interest rate of 8.8%. All right, so this is an example of solving for the interest rate given A, P, and N. So this example is going to be solving for time, which means we're going to need to know A, P, and I. So let's take a look. Aaron's parents invested $5,000 in an RESP. So that money was invested, that's the principal. And discovered it is now worth $6,092. So that's what it accumulated to. So that's my A. So I already know that the principal is $5,000. The accumulated amount is $6,092. If they invested it at 5% per annum compounded semi-annually, so we know the interest rate and the compounding period, how long did his parents invest the money? So we're looking for time. Okay, but we do know the interest rate, and that's 5%, which is 0.05, divided by 2, because it's semi-annually, so that's 0.025. Okay, let's take a look at the formula again. A equals P, 1 plus I to the n. Let's fill in everything we know at this point. We know A is 6,092. We know the principal is 5,000. We know I is 0.025. And if we can figure out n, then we'll deal with the fact that it was compounded semi-annually and actually find out what the time is. Because remember, n is going to be the time in years multiplied by the compounding period, which is 2. So if I can find out n, I'm just going to have to figure out what the number of years multiplied by 2 that's going to give me that n value. So let's see how we're going to solve for this. So just the first step is the same as actually the previous example. I'm going to get rid of the principal, so divide both sides by 5,000. 5,000 is reduced on the right. And then on the left, I get 6,092 divided by 5,000. So I am going to calculate this, and that's 1.2184, leaving me with 1.025, just adding inside the bracket there, to the power of n. Okay, so now at this point, you don't know how to solve for n. There is a mathematical way, but the way we're going to be doing it is trial and error, which simply means sit there with your calculator and just start plugging in numbers for n. Maybe just pick a number at random. Let's try 5. Let's try 6. If you see that, oh, 5's too much, maybe try 4. If you see, oh, maybe I'm getting closer, try 4.5. It's okay to have decimals. What you want to do is you want to just keep plugging in until you get 1.025 to the power of whatever number you get is going to be as close as possible to 1.2184. And of course, this is going to be an estimation. You're never going to get it to be exact. So just try your best to get as close as possible. So after sitting there with the calculator and trying out different values, you'll find that the number that works the best is n equals 8. So what does that mean? If I look back up here, 8 is not the answer. I want time in years. N simply represents the number of times Aaron got interest on that money over the time period. So I know that N is equal to time times 2. So 8 is equal to time times 2. So what if I divide both sides by 2 here? Time is going to be 4, which means that his parents invested the money 4 years ago. So therefore, how long did his parents invested the money for 4 years. And if you wanted to, I could have introduced a variable here for time, and I could have just said time is equal to t, or time in years is equal to t. Probably look a little bit nicer if I did n is equal to 2 times t, because the compounding period is semi-annually. So 8 is equal to 2t, divide both sides by 2, and then 4 is equal to t. Or you can just use the word time. I introduced it as time up here, so I just continued with that. But it would have been fine to introduce a variable there. The key point here is remembering that n is not your time. Your time is going to be some value multiplied by the compounding period. Okay, so this is the final example, the second example, solving for time. So you should be comfortable, given this compound formula equation, solving for any one of those unknowns, A, P, I, or N. And there is your homework for this evening, page 12, numbers 1 to 4. And tomorrow we'll do the follow-up.